Okay, I just want you to look at curve sketching and run through the rules where you need to use y dash. Okay, so first of all, if you have a curve, like this, and then let's just have a look at this curve here. Now, if you run a line, along here, like a tangent line, let's just touch you. You notice that the gradient of the line all along here is positive. So that's the gradient is y dash. That's always greater than 0. When you get to this point here, you notice that y dash equals 0 because the tangent line at that point is horizontal, and therefore the gradient is 0. When you keep coming around and you keep running your tangent line down here, the gradient then becomes negative. Okay, until you get to here, and the gradient once again is equal to 0. So that means that y dash will equal 0. Keep coming up here, the gradient once again becomes positive. That's a positive gradient. And you notice that it kind of curves back around. This is a little bit like this part here, looks like a cubic. Okay, now when you run it back along here, you get to a point where the tangent line there becomes horizontal. Okay, and that's where y dash equals 0. And here it keeps going positive, so it goes positive, back up to positive. Okay, so we have special names for these types of points where y dash equals 0. They're called stationary points. And you notice on this curve there are 3 different types of stationary points. This first one here, we call this a maximum turning point. And in actual fact you call it a local maximum. And this one here is a minimum turning point. Okay, or a local minimum. And this one here, at this point here, we call this a horizontal, because it has the horizontal tangent, and it's called a point of inflection. Now, a point of inflection is basically where there is a change in its concavity either side. What do we mean by change in concavity? Well, when the curve looks like the first one here, that's like that, we call that concave down. It's like a down parabola. And when the curve is going up like that, we call that is concave up. So you might notice in this first section here that if you that blue section there, up until that point there, it is all, the whole thing is concave down, that whole blue section there. And then if you look at the next section, the green section, that whole section is concave up from here all the way along here. And you get to a point and then it becomes, so you get to a point and it becomes concave down. Okay, that is that pink section there, and that's going to be there, that's concave down. Okay, so concave down is that going down like that. Okay, it can also be in this direction like that, or it can be joined up. They're all concave down, but concave up would be like that. It could be like that, or it could be a whole thing like a parabola. Okay, so if we look at this here, it goes concave down and it goes up. So when it's down, it was a maximum. When it was up, it was a minimum. If you look at this next point here, whereas the point of inflection, it starts by going down, but then look what happens in the second section. It flips around and it goes. Okay, so you notice that in this section here, it goes back up to concave up. So if you're going on this journey, you're going concave down, and at a particular point you go concave back up, concave down, then concave up. So the horizontal point of inflection is where it goes from down to up. Now a horizontal point of inflection can also go, it could also go, so it can go down to go up. It could also go the other way, to go concave up, going concave down. But what actually happens is, at that point there in the middle, the gradient line will always be 0. So if you drew your gradient line on here, when you get to there, it's going to be 0. If you're coming down this slide, when you get to that point, the horizontal gradient of the tangent is 0. And this will be concave down, and this here is concave down on this side. So that goes from down to concave up, and this one goes concave up to concave down. And they are called, as a horizontal point of inflection. It is also what's called a stationary point. Okay, now the other types of stationary points are your maximum point, and we call that a local maximum, and it is also called a turning point because it does in fact turn. So it looks like that. It has a maximum point at that point where the gradient is 0, and then a local minimum point that would be like that. That would be y dash equals 0.